Hello everyone, this is Zishan, and I thought I'd make a little demo video for my portfolio project. MedFlow Analytics is basically a data platform transforming healthcare claims into insights using AI. It's a Medallion architecture that uses Iceberg, Spark, and then RAG interface that's powered by ChromaDB and Claude. So let's dive in. Before I dive into the actual container itself, I thought I'd give you guys a little overview of what the data flow is going to look like. So our data sources is basically in a JSON format, just provider data and pair information. All of this is using Python Faker generated data, so it's not real patient data for those of you that are wondering. And then that gets fed into the bronze layer, which imitates an S3 bucket using local stack. It's it's not an actual Amazon S3 connection, but it does imitate that, so it is ready for AWS. And of course, there's no transformations going on there. It's just the basic raw data. And then from there, it gets moved into a civil layer, which is more cleaned up in a Parquet format. And then you have your metadata that is also established using Iceberg. For the data lake catalog, we're using Postgres for our cataloging system, and all the schemas and tables and everything are defined within Iceberg. And then you have your gold layer, which is your aggregated rollups that can be used for reporting and metrics that can be defined either on a dashboard or, in this case, an actual RAG application, which is going to be using this data for its own chatbot. Right, the query engine for a RAG is pretty self-defined. It'll load the schemas, it'll build the prompts, and then it'll use the Claude API SDK to generate a SQL, and then use PySpark against those layers underneath to finally return the results to a user. That's the whole concept of this. And the reason why I went with a RAG interface rather than traditional dashboard, because it is more intuitive with the type of the type of insight that you can gain just asking questions against the data using the model rather than your deterministic filters that are defined by a traditional dashboard like a Tableau, for example. All right, so I thought I would give you guys a basic overview of the Docker compose.yaml file, which creates all of the containers for this project. I'm not going to go through all of the details within the file. You guys can check out all of that from the GitHub repository itself, but I will, go give you a basic overview of what the file entails. So as we can see, you have your common parameters for Airflow, you have your Postgres container defined, you have local stack that basically emulates AWS S3 bucket, you have your initialization for the local stack, that's defining all of the names, right, for where the files are going to land. The files being for the bronze layer that are going to be generated and then uploaded into the S3 bucket, for Spark to go in and start processing it, and then load it into the Iceberg schema. And you have the Spark master. You also have the Spark worker I do only have one of the workers defined on here because it is an application that's hosted on my local sandbox, right? It's not technically on the cloud, but it does give you the basic Spark architecture. Then you have your installation for Airflow. The Iceberg cleanup, this I had to add in because as I brought down the containers and then basically started it as a clean slate. Sometimes there would be some stale entries that were remain out there, and it would cause the DAGs to fail as I would initiate the ETL process, right? So that's why I had to add this in. The thought being is once it's up in a production environment, this variable in your .env should always be defaulted to false and not true, because you don't want to lose that history, right? Being a persistent. And you have your container for the web server defined, your scheduler, and then your RAG backend, which again, the tech stack for that is your Fast API, Spark, ChromaDB for your embeddings, and then Claude as your SDK for your analytic insights. And then your front end that's based on Streamlit. I do have the volumes defined for consistency, and then they're all on one network, the MedFlow network. Then there's these each individual Docker files as well that are used within the compose.yaml, which I'm not going to go through each and every one. But again, there's one for Airflow, there's one for the backend, the piece of this around the Fast API front end for Streamlit, and then one for Spark. So having said all that, let me bring this down. And let's do a fresh Docker compose up the services. I'm going to do it in detached mode. Okay, so they're up and all created. Let me check on. Let's leave for 40 seconds and do if I can type Docker compose PS just to check and see what the statuses are. And I did this just to make sure that everything was up and healthy, because as we can see, most of these services are up, less than a minute ago, about a minute ago, so you have to give it some time. Sorry, excuse me for my voice today. So these are all up. We can, if we wanted to, we could do some more checks and phases. I think let's see. Want to check the scheduler, maybe. I'm just throwing up random. Let's see what the scheduler looks like. Looks good. Let's see. The web server is looking like. Looks good. That looks good. Let's check and see if there are no Iceberg tables in the catalog defined, which there should be none. 0. Okay, that's good. So now what we can do, we can go on to our Airflow UI here. See, it's up and running. and we should have our DAG should show up, and it is there. And what we can do is we can kick this off and then follow along to check and see that the all of the Medallion architecture layers are populated correctly. So there's two ways you can go about this, right? Apologize. Is you can follow the logs through Airflow itself, or what I like to do is just have a simple watch command on my terminal that is, just going to update every 2 seconds. You can do 2 seconds, 4 seconds, and basically check and see what the latest updates are for Airflow. So let's see here. Um, 2 seconds. Actually, you know what? Let's change that to 4. It's watching. I've already, ran this obviously before, so it's giving me the last update that when I ran this. When I click on this one, hopefully it should give me the new entry on there too. Okay, it is started. It's running. Could try to, and again, you don't have to do this. I just like doing stuff in the terminal because I like the CLI aspect of it. So, okay. So this is running. The files have been uploaded to the S3 bucket, which is good. And now it's actually ingesting it into the bronze layer. And this is also showing us that it is in fact running. So this has been completed. Now we're just verifying it. If we wanted to watch the logs that way, we could. This is actually verification complete. So you can see that it verified all the files for different pairs, right? And by the way, there are 3 type of pairs that I have allocated for my sample data. United Health, Blue Cross, and Aetna. Go back to my graph, see where it's at. Now it's in the silver layer. Still running. And I do realize this is going to make, the demo last a little bit longer, but I feel like it's good to show the end-to-end processing, right, for all of these tags. The other good thing that I love about Airflow is that you could literally just look at the code itself just to check and see what step, what tag is it actually following, right? The steps that it's going through. So that's good. Go back to our logs. So it's completed over here. Some more checking, and then we're back to our gold layer. And again, I'm not a big expert on all of the intricacies of Airflow itself, but it is a useful open source tool that can be used for various sources because it gives you connectors to so many objects. And that was the goal of this whole project too, is I wanted to use open source to basically build it out. We could, while this is running, go to our Spark UI and see what the workers are up to there. Well, this is actually complete. So let's close this out. This is complete, and this is also saying that's been completed. Okay, so that's good. So now you can actually check if we wanted to our Swagger UI for our Fast API application. So, this basically shows what the implementation is, what the flow is. Obviously, you're building the prompt, with the table schemas and all the rules. You're generating the SQL using the Claude API. Then you're validating the SQL. Then you're executing it via Spark, and then you're generating the explanation and then returning the results in the natural language. So to prove this out, this can send a curl request if we wanted to. Execute. And here we have the results, right? It gives you the SQL that's using the data that's being generated, execution time, session ID, and all of this is basically being done for us using our front end, which is this right here. All right, so this is the front end that's basically being built using Streamlit. On the left-hand side, it gives you just some basic system statuses. You have some sample questions too if you wanted to ask. Or you could just start chatting yourself. So let's ask you something. Let's start with show me the monthly claim trends for all pairs. Let's see what it comes back with. So the nice part about this is that it does give you a data frame type of a output. You can download the data. It gives you, but it also puts this visualization using Plotly, right, where it gives you a line chart or the graph that it generates based on whatever your query is, right? That's where the intelligence of an LLM comes in. And it gives you the query metadata too. I think over here it should give you the SQL as well. Yes, it does. So shows you exactly which schema it went to grab the data, which is quite nice. Let's ask you something else. Let's see. Show me denied claims for Blue Cross with amounts over $1,000. See what it says. Okay, nice. So again, you can chat through it if you wanted to pick something that's already defined for you. You could. What are the most common diagnosis code? What are the most expensive procedures? What are the most common diagnosis code? And it gives you the diagnosis code. If you wanted the aggregated metrics specifically, I know we looked at one just now. You could look at other metrics as well. And again, it does generate, some plotly graphical visualizations for you as well, which is quite nice. So that's basically the gist of my portfolio project, right? The goal was to use open source stack and then build a data lake type of an architecture. Your storage bucket is going to be S3, and then use Airflow as your orchestration tool to move the data across all of your layers, apply some data quality checks, and then for the front end piece of it, there was two ways that I could go about. I could have just easily went, I'll just build a traditional BI dashboard on top, and that should be fine. But my interest that peaked was, well, what if we can use some of these agentic AI options that we have available and build sort of like a RAG application that can answer questions for us rather than giving a dashboard where your filters are locked down and your options are your options. So hope you guys like my project and hope you have a good rest of your day. Thank you very much.